Hi everyone, good evening and welcome to the class. I can see Gargi is here and she's wishing good evening to all of you. Shooting star, what's your name? Saranya, Abhinay, Aditi, Archit. Good to have you back, guys. Hey Ritu, I'm doing really well. I hope all of you are doing absolutely fine too. Hey Venkat, Archit, Ashwamedh. Good evening, all of you. Quickly let your friends know about the class. Ask them to join in and then we get started. Good to know that, Ritu. Great. So how many of you are actually revising the topics that we keep studying? Like right before the class, right before the next class, how many of you are actually, revising, reinforcing the important points that we've discussed in the last class? Let me see. How many sincere students do we have here? I see some of you writing me. The young scientist, good evening. Ashi. So many of you are revising. All right. Great. So, in the last class, we discussed about the effect of temperature. And today, we will be talking about the effect of pressure. Temperature, we all know, had some effect on the matter, the changing of matter, the states of matter. What about pressure? This is what we will be figuring out today. Yes, Saranya, absolutely right. So, Saranya has revised the class. Hi, Tally Paul. Great. Good to know that, guys. So, Gargi is saying I revise everything right after the class. And this goes for every subject. Hey, Saksham. Future millionaire. Future millionaire तो पक्का ही revise कर रहा होगा, I'm sure. या कर रही होगी. Hey, Salma. Hey, Mani. Ashi, Nitya. Welcome, guys. Very, very warm welcome. We'll just wait for a couple of minutes. Let all your friends join in. Meanwhile, I can tell you about this wonderful app that is BYJU'S, the learning app. How many of you have downloaded this app? Because if you have downloaded, if you're actually exploring, you will find a lot of interesting stuff out there. A lot of practice questions are there. A lot of tests are there. So many videos are there. The same concept is being taught in such innovative manner. Full of visuals, and audio visuals are always the best way to learn anything. Great, I see a lot of you have this. Good to know that. Yes, Archit, correct. We will be coming to that point really soon. Good to know. And I can see somebody's writing about the scholarship. So yes, I hope you all have registered for BYJU'S scholarship test because you're in grade 9, right? So it's applicable, definitely applicable in your case as well. Grade 4 to grade 10, all boards inclusive. You can test your conceptual understanding and aptitude and understand where are the gaps. And then work on those gaps, fine-tune your study pattern accordingly, right? And yes, the happy news is about the free registration and the scholarship that you can get. Correct. So this is happening every Sunday. I hope you've done this by now. If not, coming Sunday, go ahead, give the scholarship test and analyze your performance. It's very important that we keep analyzing our performance, from time to time. Amazing. Good to know that you found it really amazing. 100%. Awesome. Great. All right. So before we kickstart, before I dive straight into the session, before we understand what role pressure is playing, if at all it is playing any role, then before that, quickly give me loads of thumbs up, loads of smileys. Let me know if I'm perfectly audible, visible or not, and then we get started. Quick thumbs up in the comment section, smileys. Any interesting emoji. I want the chat to keep, just keep flooding the chat with your replies. Make this live session really lively. And let's see who's going to interact the most. So towards the end of the session, I'll actually, name the person who's been really active in this class. Great. Now I can see the chat box is moving. Finally, you people are super duper excited now and we can get started. Yes, I'm definitely noting who's writing what and who's writing the most, who's interacting the most, who's the most active child of the class. Good. Alright, so there was a homework question given to you, and first of all, let's see who has done this homework question. Then we'll discuss the solution as well. So if I take your name, you have to flood the chat box with any interesting emoji of your choice. And let's see who all have done it. I can see some of you are already, posting raised hands out there. Great. Alright, so Lakshmi, Gargi, Chitramani, Vidhi, Saranya, Mona Lisa, study notes, post your name over there. Venkat, Manjeet, Archit, Prachi, Janani, Rafiq, Anshi, Om Shankar, Kavita, Prashansa, Pragati. All of you have done the homework question. Great. See, I always feel that you should definitely attempt these questions. It's just one question, right? One question right after the class. This will help you to monitor your learning. You will actually understand how much you've learned in these 30 minutes, in these 40 minutes. What is your learning? You can analyze by solving that question. Because once we get the answer right, I think it's a great feeling, isn't it? Hey Art, how to do the homework? You just have to post the answer in the comment section right after the live class. Good to see that. Archit, by the way, is posting a lot of emojis. Is quite active right now on the chat. And so is Prashansa. So I'm noting who's interacting the most, okay? And towards the end, I'll tell you who has been really active. Alright, so the question was, what is the difference between boiling and evaporation? So we keep getting confused between these two terms, right? What is boiling? What is evaporation? Let's understand what the difference is. When we talk about evaporation, it's a surface phenomena. While when we talk about boiling, that is a bulk phenomena. Evaporation occurs at all the temperatures below the boiling point, but boiling occurs at the boiling point only. So, evaporation also causes cooling effect, and that is not the case with boiling for sure, right? So, these are the major differences. So, if I say that the temperature is say about 50 degrees Celsius, will water evaporate or will it boil? Quickly let me know in the comment section. Yes, Prashansa, absolutely right. You've seen the score booster. Good to know that. So yes, tell me in the comment section. 50 degrees Celsius is going to boil. Is it going to evaporate? Give me this one word answer so that I know that you've understood the concept. And give me a unanimous answer because I think this is a very basic concept. Nice. All of you saying evaporation will take place, and with this, I have a smile on my face because your answer is absolutely right. So let's get started. Now, in the last class, till now, whatever we've discussed, we'll quickly brush that up, okay? We discussed that, solids on heating, they get converted to liquid and, in a way, melting is taking place. Now, liquid can be cooled back to form solid by the process of solidification. Similarly, if you have liquids with you, then what is the effect of change of temperature? If you heat a liquid, vapors are formed by the process of vaporization, and these vapors can be cooled back to form liquid by the process of condensation. Now, what do we have to think? Is it possible for solids to change into gases directly without coming in the intermediate liquid state? Let's see. Who's going to answer this? Directly from a solid to a gas. Saranya, Archit, Ashi, a lot of you are saying yes. All right. Well, the answer is yes, and the process is going to be sublimation. To know more about sublimation and deposition, download BYJU'S the Learning app, and you'll get great visuals out there. You'll understand the concept of sublimation and deposition in the best possible manner. So to know more about these two processes, you know what you have to do. You have to download this app. Yes, absolutely, sublimation. Great. All right. Now, till now we've discussed the role of temperature, right? We know about this. Now, is temperature the only factor? What do you think? Is it the only factor responsible for the interconversion, or there are other factors too? You have to be really, really interactive. Come on, guys. And, hey, Saranya, absolutely right. I see a lot of you right. No, there are more factors. And we will be discussing about those. So, in today's class, we will be talking about pressure. We'll be talking about the effect of change of pressure on matter and specifically on gases. So, let's get started now. So, we're using this term pressure. Let's understand what's the meaning of this term pressure. It's basically the physical force applied on an object. So, pressure is defined as the force acting per unit area. That is pressure. How many of you already know what pressure is? Because I'm sure you must have heard this term in physics as well. Force per unit area. So basically physical force applied. Good, I can see a lot of you writing me. So you know about pressure. Now what happens when we actually apply pressure to the various forms of matter that we have? Well, let's understand this. But before that, we need to understand a very important point over here. We've already discussed this point of interparticle space. It's very much connected to this topic. So we'll quickly recall this and then we will get started. Alright, in case of solids, what happened? You can see over here. What is happening is that the space is negligible. There is hardly any space. In case of liquids, the spaces, interparticle space between the particles is more than as compared to solids. And in case of gases, there are a lot of spaces. So, if you have to place the order, this is going to be maximum in case of gaseous particles. Yes, absolutely right. So, you remember the space point, right? Okay, keep this in mind because we're going to apply this really soon. Now, it's time to learn in a very innovative manner. Let's go to a virtual lab. Okay, let's go to a virtual lab and understand what needs to be done. Yes? How many of you are super excited? Let me know in the comment section. Super duper excited for this. Let's see. Some of you are writing cool, so you're super duper excited to enter the virtual lab. Yes? Great. Awesome. So there you go. You can actually do whatever in this lab, right? You can place whichever angle you like the most. Let's see what do we have here and what are we going to do here. Okay. What can we see? We can see 3 syringes are being placed over here. Yes? Everybody can see the screen? I hope I'm not hiding any text. Great. Alright. So you can see this is syringe number 1, this is 2, this is 3, and you can actually, move it in whichever way you want to know the angle as well. And then you see a beaker out there. Can you see the beaker? That beaker, it contains water. And there's a chalk piece also. Great. Alright. You can see all this, right? Okay, now let's do one thing. Let's fill water in the middle syringe. So the first syringe has air in it. It's definitely not empty. It's not vacant. If you think that nothing is in it, you might want to rethink because there is air present in it. In the second one, we'll fill water. Ready? If you'll give me a green signal, then we'll fill water. Only after your green signal. So I tell you, in these interactive sessions, I will do as you tell me to do. Quickly. Great, Gargi has given loads of green ticks. So, let's do one thing. Let's set the angle and let's fill water in the second syringe. Now, let's do one thing. Let's fill chalk in the third one. So, there you go. We are filling chalk. Now, over here, let's just place the corks quickly. So, there you go. Now, all set to compress. Let's see what happens when pressure is being applied. So let's compress. I hope all these 3 are perfectly visible to you. Yes? Alright. So let's compress. So we, in a way, we are having some pressure over here. Only in case of the first syringe, you can see that the height has gone down. The height of the syringe that you have over here. Why? We'll discuss that. But this is the observation that we are having. Yes? Clearly you can see the difference in their height. Yes? In case of liquid, that is water. In case of chalk, that's a solid. It's just the same. But yes, over here you can see the difference in case of air. If yes, give me loads and loads of thumbs up that yes, ma'am, we could definitely figure this out. Prashansa, you're absolutely right. Great. So let's switch back and understand what has actually happened over here. Let's switch back to see what is happening. Why is this happening? I see loads and loads of thumbs up over here. Good to know that you've made the observation. You could clearly see what has happened over there. Now, what is the effect of pressure on solid, on liquid and gas? Let's individually understand that. You've seen what has happened. You've observed what has happened. Now, when solids were being tried to compress, when there was a chalk over there, it was not possible to compress, right? They were incompressible. Why? You have to connect it with the interparticle space. I told you to keep that in mind, right? Due to the negligible interparticle space. See, when we compress something, what happens? Space between the particles, it decreases and particles come closer. But there is already no space. So therefore, in a way, it is showing negligible compressibility. It's not able to compress because of the negligible interparticle space. But if you will still continue to apply, कि हम तो apply करेंगे pressure, what's going to happen when excess pressure is applied? Well, it's going to break, as you can clearly see over here. Yes? Awesome. So if you've understood what happens in case of solids, loads and loads of thumbs up. And then we move on to the next one. Yes, in case of solids, they're already tightly packed, really closely packed. Particles are very close to each other. So they will break if excess pressure is applied. And now I can see Ritu is posting the most. So I am still figuring out who's going to be that one person who's been interacting the most. And Archit is back. All right. Okay, now in case of liquids, what happens? Well, let's see. When we try to compress, when we try to apply pressure in case of liquids, again, negligible compressibility was observed. It is very difficult to compress a liquid. They can actually adapt to the shape of the container, but it's very difficult to compress them, right? So, we clearly noticed this, that this was not possible. Now, let's see what is the effect of pressure on gas. So the first syringe that you saw over there was containing air, which is a mixture of gases. Now, when you try to compress it, what happens? We can actually compress gases up to a great extent by applying pressure. So we can say that gases are highly compressible. Yes? And this property of compressibility is, by the way, very useful for us. Absolutely right, Archit. Prashansa, Ritu. Yes, Ritu, correct. Ritu is talking about LPG. I said, you know, this property of compressibility is very important, and she stated why it is very important. Good. So we use LPG cylinders at home, right? That is one application of compressibility of gas. Let's see how. Absolutely right. So, over here, first, let's understand. You must have, you know, we've discussed this, so I'm sure you must remember this as well. When weight and more weight is being, you know, put over here, what happens? Gases become highly compressible. The particles come closer and the space between the particles keeps on decreasing. This we've discussed, right? So, the application, first application of this is liquefied petroleum gas, that is LPG cylinders that we use, right? But hey, why is it called liquefied? Yes, Himani mentions about CNG cylinders. So, that is of course a fuel used in vehicles. There also the same concept is applied, correct? So, Himani's been the latest one who's posting a lot of comments. Good. Alright, coming back to LPG, and why is this called as liquefied gas? Let's understand this. See, when we talk about gases, if actually we are increasing the pressure, what's going to happen? The space between the particles is going to decrease. In a way, we are decreasing the spaces by increasing the pressure, and of course by decreasing temperature also. So when we have these three factors here, what happens? Gases become highly compressible. They in a way compress. When you apply pressure, particle space is decreasing. When you decrease temperature, when all this is being done, the gases are in a way compressing, and this is liquefaction. So there's a new term out there that you can see. Let's understand what this term basically means. Liquefaction is really simple. I think it's in a way self-explanatory. It's the change in state from solid or gas to liquid, which basically means from solid to liquid or from gas to liquid. Ultimate destination is liquid, and this is known as liquefaction. So maybe from a solid you're going here, or maybe from a gas you're going to a liquid. So in any case, as I told you, the final destination is when the liquid state is being achieved, that is liquefaction. So in a way, we can relate it with melting also, right? What happens in melting? Solid gets converted to liquid. We can relate it with condensation also. So vapors are getting converted to liquid. So if liquefaction is crystal clear, let's see who's going to post the maximum smileys in the chat box. Who's going to post maximum thumbs up? Who is actively participating in the class? Prashansa has given loads of smileys. So has Imani. Chitra, Gargi. Oh, it's going to be really tough for me to decide towards the end of the class who's been really active. Venkat, Future Millionaire, Jyotika, Adarsh, Saranya. Great. All right. Yes, the chat box is looking really lively now. So, now I'm sure you know why is this called liquefied petroleum gas. Why? The gas is in its liquid form, and that is being stored at a very high pressure. So that is why it is being named so. Moving on, of course, CNG is definitely on the same lines, and you can definitely now correlate the topic. Another real life example that we have is over here, solid carbon dioxide. That is also being stored at very high pressure. Solid carbon dioxide. Have you heard about this? Yes, absolutely right. I see some of you have. But why is it being stored at high pressure? What happens at low pressure? Why do we have to store it at high pressure? See, if the pressure is low, that means at low pressure, it gets converted directly to the gaseous state. If the pressure is decreasing to 1 atmosphere to 1 atm, this solid carbon dioxide gets converted to the gaseous state. That's why we have to store it at high pressure only. And by the way, this solid carbon dioxide is also known as dry ice. So if you heard this term anywhere and you must be thinking, what is dry ice? It is solid carbon dioxide. Correct. Absolutely right. Yes, it does. Now, you know about this, right? Earth's average pressure, we've already discussed. At the sea level, it is 1 atm. It's 1 atmosphere, right? But it, in a way, decreases with the increase in altitude. So, it's not the same everywhere. Yeah? Alright, next, another real life example. See, compressibility is something that's, very, very useful for us. That's happening around us. We are just letting you know the example so that next time when you come across such an example in your real life, you can know the chemistry behind this too. Because as we keep telling you, chemistry is in everything. It's all around you. It's happening around you. If you have the right vision, if you have the will to figure out where it's happening, how it's happening, I'm sure you'll reach the destination as well. Okay, oxygen cylinder. So, oxygen is also compressed at very high pressure, right? And why is it done? So that, large amount of oxygen can be, in a way, stored in a single cylinder. And we all know about this, right? In hospitals, so many oxygen cylinders are there. Yeah? So we compress it so that we can save large amount. Yes, I saw somebody was writing about oxygen cylinders also. Good, good, absolutely right. Hey Manjeet, I think you've joined a bit late. You can always go back, watch the video again. Yes, Nitya. Aditi is being really responsive right now. Good to see loads of thumbs up. She's understood all the real life examples. So has Prashansa. And Gargi. So many of you. Great. Alright, so since you've understood everything, I have a quick question for you. Which of the following substances will show sublimation at reduced pressure? So remember what is sublimation and try this out. Is it A, ice, B, common salt, C, oxygen, or D, solid carbon dioxide? Think about this one. Read all the options very carefully and then answer. I can see all of you voting for option D, that is solid carbon dioxide, and big smiley for all of you because you have answered it correctly. Chat box is just flooding with solid carbon dioxide, which is also known as dry ice. So yes, if the pressure is reduced to 1 atm, it's going to be converted directly from a solid to a gas. Correct. And somebody had this doubt also. Is it undergoing sublimation? Now you've got your answer, isn't it? Correct. Hey Sakshi, good evening. Absolutely right. So this is, in a way, you can, correlate all the important topics at once. You know the effect of pressure now. You know sublimation. You know about temperature. You know about all these things. Hey Ritu, so good to read that. Nice. Hey Anshan, grade 10. Alright. Okay, so yes, the correct answer was option D. As you people have mentioned, that is indeed the correct answer. So if you've understood the role of pressure, quickly like this video and then we move on. Then we go ahead. Great. Already liked. Thank you so much. See, it feels really nice when you encourage us. So go ahead, like this video and then let's move on. So, when we talk about interconversion, we can safely conclude, it is safe to say that now that pressure and temperature, they both are in a way determining the state of matter. They both can lead to the conversion of state. Individually, we've discussed both of these factors with you. Great, Ashi. Alright, so let's quickly summarize everything. We have a lot of information out there right now. Let's put everything together on this single slide over here. So, solid getting converted to liquid is happening when you heat it, and the process is fusion. Now, liquid getting back converted to solid is solidification, or you can also call it freezing. From liquid to vapor if you're going, that is vaporization, and from vapors if you're getting liquid back by cooling, that is condensation. Now, if a solid is getting directly converted to a gas, you know the process is sublimation. If the reverse is happening, gas getting converted to solid directly, that is deposition. And in both these cases, they are not getting converted into the intermediate liquid state. That is not happening, right? So, direct conversion from solid to gas or from gas to solid. If you've understood, I want to see loads and loads of thumbs up in the chat box. And yes, I have a homework question for you. So, you have to wait till I show you the homework question. Because I see a lot of you are actually taking out time, are actually working on it, answering in the comment section, and that feels really nice. Great, awesome. So stay tuned. I'm going to show you the homework question as well. But I hope, before that, I hope all of you have joined our Telegram channel because you get all the updates out there. Session PDFs, revision questions, homework questions, interesting facts. You'll know all the updates. You'll know about the new things, everything out there. The link is there. So join us on Telegram as well. And of course, we've got you covered. We keep telling you this, that, BYJU'S, it's a quality-driven channel. We are here to provide you quality education, and I hope you all are enjoying all these sessions that we are setting up for you. If you have any suggestions for us, if you have any feedback, if there are particular kind of sessions that you want us to take, particular topics that you want us to take, you can always let us know in the comment section, because we definitely read the chat. We personally read all the comments that you post, and we try to act on it. So yes, go ahead, let us know what is in need, what is that you demand from us, and we will definitely be back with all those kinds of sessions. So yes, definitely guys, we've got you covered. There is nothing to worry about that. And the next really important information about BYJU'S classes with 2 teacher advantage. So I think the name is self-explanatory. You try this out and you'll actually understand that there's one teacher clearing all your conceptual doubts, giving you conceptual clarity basically. Another one giving you answers to your doubts instantly. That is the best part. Plus so much more is there. You can actually evaluate, get feedback. Everything is going to be there. But what do you have to do? You have to try out the link that is being given to you in the description box. Try this free trial class and I'm sure you will just love it. So go ahead, link is there in the description box. And now is time for the homework question. As I told you, I'm going to show you the homework question. Now, the question says, why does pressure affect the gaseous state of matter the most? So why is it that pressure is affecting the gaseous state the most? So this is what you have to answer. Think about this. We've discussed the answer in a way in the class. You can mention your answer in the comment section below and we will be discussing this in the next class. And the best part is I know a lot of you attempt these questions. So I'll be waiting for your answer. And yes, I also feel very nice when I read out your name, when I call out your name, because it gives me, a sigh of relief that you've understood the concept. Awesome. No, Saranya, not yet. Great. Last but not the least, quickly like this video guys, subscribe to our channel and hit this bell icon so that you get notified about everything. Great. I had a lovely time with all of you. I hope you also enjoyed this session. You found it interesting, you found it informative. So keep exploring the magic of chemistry and I'll see you in the next session. Take care. Bye-bye.